So, in the previous lecture, we have seen about some important terms regarding surface tension. Like your first term we have seen, which is nothing but as the intermolecular forces. And under that, we have seen two forces. One is cohesive force, another is adhesive force. Second term we have seen, which is nothing but the sphere of influence. Then third term we have seen as a molecular range. So for this sphere of influence, radius is equivalent to intermolecular range. Then we have seen a surface field and free surface. Now all that terms I am going to use under this explanation of the topic as a surface tension on the basis of molecular theory. Now what we are going to consider here? We are going to consider here as a liquid is inside the container. So here is we have taken a liquid in the container, and this XY will act as a free surface of that given liquid. Now free surface means it is the interface. XY surface is the interface between air medium and water medium. Clear? Then this X dash Y dash, this surface is approximately at a distance of intermolecular range. So the thickness between XY free surface and X dash Y dash, the thickness between that two surfaces is nothing but equivalent to intermolecular range. And therefore, I can say that the region between X dash, Y dash and XY, this region that I am going to call it as a surface film. Then here, two terms we have seen. Free surface, XY is the free surface, and the region which is enclosed between free surface and X dash, Y dash, which is below XY at a distance of R, that is intermolecular range. So the area between these two surfaces is to be called as your surface field. And inside this liquid, we have considered the three molecules. In that, first molecule is nothing but A molecule. Now, if you are seeing, this is your A molecule. This A molecule is completely inside the liquid. Now, as it is completely inside the liquid, this A molecule will be surrounded by the water molecule only. Therefore, there is a force of attraction between A as a liquid molecule to the adjacent corresponding liquid molecule. So, there will be a force which will be acting in all possible directions in the surrounding region of A molecule. And that force is nothing but your cohesive force, because it is the force between same type of liquid molecules. And here I have drawn around this molecule A, I have drawn a sphere of influence whose radius is equal to intermolecular range. So your cohesive force will remain effective inside that sphere of influence. But that A molecule will be surrounded by all same type of liquid molecules. So every molecule surrounding to A will exert a cohesive force whose magnitude is equal, directions are opposite. So the net force, net cohesive force acting on that A molecule will become 0. Right? And therefore your molecule A will remain inside the liquid. Right? Then I can talk about molecule B. This molecule B is in the surface film. The location of your B molecule is in the surface film. Therefore, the sphere of influence which is drawn around that A molecule, the most of the part of the sphere of influence is inside the liquid. So most of of the sphere of influence part is more inside the liquid, while very small part of sphere of influence is in the air medium. See here, this upper part will be remain in the air medium. Means now on this B molecule, there are two type of forces is going to be acting. The sphere of influence whose lower part lies in the surface field. So in the lower part, there is a cohesive force. So cohesive force will remain active in the lower part of the sphere of influence. And there is an adhesive force. This adhesive force will remain active in the upper part of the sphere of influence, where air molecules are present. Is it right? But yesterday we have seen that is cohesive forces are always stronger as compared to adhesive forces. So these adhesive forces are weak. So on A molecule, though both the forces are acting, but the magnitude of cohesive force, which is acting due to the lower part of the sphere of influence, is stronger as compared to the weak adhesive force due to air. And therefore, the net force acting on the B molecule is a cohesive force due to liquid, and hence your molecule B will remain inside the liquid because its adhesive forces are more effective. Then, now we can think about the C molecule. Now, this C molecule is lying on the surface. So, your C molecule is present on the surface. So, see here, C molecule is present on the surface. So, its sphere of influence, exact half part of the sphere of influence, so half part of sphere of influence is above the surface, where your adhesive forces are effective. And at the lower half part of the sphere of influence is inside the liquid. And therefore, there is cohesive forces are effective. Means half part gives the adhesive force, half part gives the cohesive force. But still, what is the thing? The cohesive forces are stronger than that of adhesive forces. So here, though the C molecule is partly under adhesive force, partly under cohesive force, but still the magnitude of cohesive force is greater than that of the adhesive force. So what cohesive forces are there? Cohesive forces are of due to liquid. So that cohesive force will push down the C molecule. So cohesive force are more effective, so they will be pushing the molecule, pushing C molecule inside the liquid. And therefore, your all A, B, C molecule remains inside the liquid. And therefore, the surface area, whatever now C molecule is a representative of all molecules which are present on the surface area. So all the number of molecules which are present on XY surface area, for all molecules, the cohesive forces are more effective. So all molecules are remain to be pulled down inside the liquid. And therefore, the upper surface area is tried to minimize its area, and it will remain in the form of stretch membrane, in the elastic membrane, which will create a tension, and that tension is to be called as your surface tension. So why the surface tension term comes there? That is, all molecules which are present on the surface have a tendency to move or to push down inside the liquid due to more effective adhesive forces, So the surface area is trying to minimize it, and it is trying to minimize it. Therefore, it will remain like a stretch membrane, like a membrane under tension. And that term is to be called as your surface tension. And yesterday we have seen that surface tension is acting over the surface, and that surface tension is acting along is nothing but the tangential force, which is acting along a imaginary line. And that we have seen yesterday this figure. If this is the surface area, then over that surface area, a tangential force is going to be act over this imaginary line. So this tangential force is trying to tear the surface area, trying to stretch the surface area, which is to be called as your surface tension. And that surface tension is nothing but the tangential force acting over the surface area along the length per unit length is to be called as your surface tension. Then from formula, its unit is Newton per meter. Then also we have seen its dimension. Dimensions are m raised to 1, l raised to 0 and t raised to 1. Why? Because dimensions of force will be divided by dimensions of F. Clear? So this is about your topic, surface tension on the basis of molecular theory. So here is your theme of question. Explain the concept of surface tension using the molecular theory. So while explaining that, you have to consider the three molecules. One molecule complete inside the liquid, second molecule present in the surface film, and the third molecule is present over the free surface of the given liquid, and using that reaction. Got it? Fine. Now the second term which I am going to show here, that second term is nothing but which is to be called as surface energy. So now we can say here as second term, which is nothing but your surface energy. So here same diagram we are going to refer as that of your previous topic. And now I am going to consider the term which is to be called as your surface energy. Now what the surface energy is? Clear? Now see here in this diagram already we have seen three molecules, A, B and C molecule. Now how that A, B, C molecules are representative? A molecule is a representative of all molecules which are completely inside the liquid. B molecule is a representative of all molecules present in the surface cell. And C molecule is the representative of all molecules present on the free surface. Now just now we have seen that on A molecule the effective forces are, I can say that effective forces are nothing but the cohesive force. And that cohesive force tries to maintain your A molecule inside the liquid. Right? Then B molecule. On B molecule, both the forces are there, adhesive force and cohesive force. That cohesive forces are greater than that of your adhesive forces. So magnitude of cohesive force acting on the molecules which are present in the surface film is more than that of the adhesive. Therefore, due to action of this cohesive force, all molecules which are present in the surface film tries to remain inside the liquid. So again they will try to remain inside the liquid. And the C molecules which are present over the surface, there also the magnitude of cohesive force is greater than the adhesive force. Therefore, they will again remain inside the liquid. Right? Means every molecule has a to be tendency that the cohesive force will be acting on the molecule and try to pull down the molecule inside the liquid. Is it right? Now, if I want to bring this A molecule from inner side to the free surface, so at that time I have to do the work against the cohesive force, and that work done is to be called as your surface energy. That you want to bring inner molecule over the surface. So we have to do the work against the strong cohesive force. So that work done against the cohesive force is to be called as your surface energy. And this surface energy is always stored in the form of potential energy. And this potential energy always minimizes the surface area. This potential energy has a tendency to minimize the surface area. Right? So this is nothing but your concept of the surface. And now we can relate surface energy and surface tension. So that is our third topic, that is how we can relate the surface energy and surface tension. So that is a 2-mark question. Derive the relation between surface energy and surface tension. So we want to derive the relation between surface energy and surface tension. For that purpose, what I can do, I will take a rectangular frame as a P dash, P, S, S dash. And here is the QR, a movable wire. Now what I will do, I will dip this rectangular frame in the soap solution. So whenever I am going to dip this rectangular solution inside the soap solution, a soap film is formed over the rectangular wire PQRS. So this soap film will be formed here, and this soap film always wants to minimize the area. So on the soap film, the forces acting on QR is towards the PS, because it wants to minimize the surface area. It wants to minimize the surface area, therefore a force act which is acting on QR wire towards the PS due to concept of surface tension. Right? Now if I am saying that this is nothing but your length L, SR part is nothing but the length of that rectangular frame. Is it right? Now, if I want to apply a mechanical force F dash, which is equal in magnitude as that of F, but opposite in direction. So due to that, what happens? This QR wire will get shifted to the new position as a Q dash R dash through a certain displacement, which is nothing but and what we are doing? We are doing a work to shift the QR wire to new position Q dash R dash against the force, cohesive force. Right? So that work done is nothing but F into dx, that is force into displacement. Right? Which work? I'll say F dash. F dash is the force which is applied on QR wire to get displaced through distance dx against the cohesive force acting on the surface plane. So I'll write down this F dash. Now what we are doing that? Magnitude of F is equal to F dash. And what is F? F is nothing but, I'll say T into 2L. Now how? See here, we have seen surface tension is equal to tangential force per unit length. Right? But I am taking here 2L. Why 2L? Because over the surface film there are two layers, upper layer and lower layer. So upper layer length L, lower layer length L. So total length is 2. So therefore what I say that this F I am getting as a T into 2L. So that F I have substituted here. That is F is equal to F dash, which is equal to T twice L. Therefore work, what I say this, work is equal to T 2L into dx. Is it right? And 2L into dx. So that 2L into dx is nothing but the, here I can say that area square. Through this distance, your area will get squared. So what I say that here, I will say that this work done, that I will write down in the form of this work done. I can find out as a here 2L into dx is nothing but d3. That is the area square. When a force is acting on QR, so it will get shifted towards Q dash R dash. And therefore I say that work done per unit area, which is nothing but your surface tension, is to be called as your surface energy. And this surface energy is stored in the form of potential energy. So what is this dA? This dA is nothing but your increase in the surface area. Because you are pulling your QR towards the left hand side. Is it right? Therefore, the area of the film will get extended. The area of the surface film will get increased. How much area? L into this dx. So this is nothing but L into dx. That is nothing but the extended area. So this dA is nothing but the increased area. So work done for a solid film to extend its area is equivalent to surface tension, which is to be called as your surface energy. Right? So this is your 2 mark question. Relation between surface energy and surface tension. And this problem is very important for your numerical problems. So this formula is important for the numerical. Got it? Any doubt? So see here. In today's lecture, we have seen three important points. What is the first point we have seen? That is how we can explain surface tension on the basis of molecular theory. Right? With the help of that 3 molecule diagram. Then we have seen what is surface energy. And the third part we have seen what is the relation between surface energy and the surface tension. So this question can be asked for 2 marks. Is it right? And molecular theory can be asked for 2 marks. Fine? So today I am going to stop here. In the next lecture, we are going to consider the concept of angle of contact. So that angle of contact means what? It depends on which factor. What are the characteristics of angle of contact? Why the liquid will get convex shape meniscus, concave shape meniscus. All that part we are going to see in the. Fine?